All right, hi everyone. Once again, in this video, we're going to be looking at Waec 2024 physics practical, this time around electricity. So this is the first video that I'm going to be doing on electricity. So you're going to probably see a setup like this. You have a resistor labeled RS equals 1 ohm. It could be any labeling, but this is exactly what you're going to get, or something like this. And you have a resistant wire labeled L. So the L, they have two, so one may be labeled L1 and the other one L2, or it could be labeled LA and the other one labeled LB, depending on what you can get from the question. And again, this can be replaced and put here, and this taken away from here and placed here. Whatever way, you're still going to get the same result based on what we are going to do. So in this practical or in this video, I am actually going to use a cheat code to arrive at my reading. I have already done the background work and every other thing. So what I've just showed to you in this video is to walk you through simple steps that you can actually use to get your readings easily. Now the reason why I'm doing this is because in electricity sometimes you find it very difficult to get your readings easily because of the instrument. Most of the time the instrument, when they get old, they begin to malfunction. Okay, without much ado, let us quickly move on and see what we are to do. So you are provided with two resistant wire labeled A and B, a 1 ohm standard resistor labeled RX, and other necessary apparatus. Connect RS in the left hand gap of the meter bridge. So as you can see here, so on the left hand side, a length L 100 cm of wire A in the right hand gap. So the wire is 100 cm and it's labeled A. It could be labeled any other thing, like I said from the beginning. And the right hand gap and the apparatus are shown in the diagram above. So every other thing is shown, like you have the cell, the key, the rheostat. Okay, so determine and record the balance point P on the bridge wire NQ. So the bridge wire is NQ, so this is the balance point P. So the balance point always represents the length of LS. Okay, that will always represent the length LS. So you're always asked to record P, so you have to record that, whether it is the length of LS or not. So you have to record that. Then determine array. Okay, so then the next thing, and you measure and record LS, which is NP, the length of NP, and LY, which is the length of PQ. So this basically very easy. Once you get LS, so just subtract it from 100, you get LY. So the bottom line here is for us to get LS first. Once ever we get LS, we can just easily get LY by subtracting those values. Okay, so we have done that. Then evaluate R1 equals LS over LY over LS times RS. So you have to evaluate RI. Okay, so you get that evaluated. So repeat the procedure for 4 other values of L equals 80, 60, 40, and 20 cm. Mind you, in the question, the length may be different from this. Okay, but it's still the same procedure. So in each case, determine and record the balance point P. So you see, you have to record the balance point P. Okay, so record the balance point P and the length LS and LY. Also evaluate R1. So your balance point P is the same as the length LS, because it's just going to be the length like this. So whatever you get at P is going to be your balance point LS, but you're asked to record it, so just record that also. Now repeat the experiment with the second wire B. So you have to remove the first wire and put the second wire B. Obtain the balance point P and the value of LS and LY. Evaluate R2 is equal to LY over LS times RS. In each case, tabulate your reading. So you see, the same thing that you have done in the first part is what you are going to do. So plot a graph of R2 on the vertical axis and against R1 on the horizontal axis. Okay, there's something that Waec did in the last practical exam. They, instead of using the vertical axis and horizontal axis, they said you should plot on the abscissa and the ordinate. So the abscissa is the horizontal axis, while the ordinate is the vertical axis. That's the y-axis represents the ordinate, and the x-axis represents the abscissa. So in case you are asked that, that's simply what you should do. So that should not be a big deal. So determine the slope x of the graph, evaluate k equals root x, state two precautions taken to obtain accurate results. So we may list some precautions that you can get from this. Okay, so what I'm going to do, I'm going to leverage on the fact that if I can get the resistance per unit length of the two wires, e.g., I'm going to use I can use Constantine wire of different diameters. So once I get Constantine wire of different diameters, I can get their resistance per unit length. So two resistance wire of different diameters, they are going to have different resistance per unit length. By the way, I've already worked out this and I've obtained my resistance per unit of two Constantine wire of different length. I can okay, so this is the resistance per unit length of wire A, of resistant wire A. I've already obtained the diameter. The diameter is 0.4, so I use that to obtain the resistance per unit length of wire A. Then that of wire B is 5.1 times 10 to the power minus 1 ohm per meter. I've already also obtained this by using the diameter. The diameter of the other wire that I used was 0.35. So you see they are the same, though they have the same material, but they have different diameters because they always have the same resistivity, even though they are made of different diameters. So it doesn't really matter. You can use wire B as your wire A and wire A as your wire B, because that's not provided. Just provide two wires of different material. It could be the same material of different diameters. You are fine with that. It could be different materials entirely. Like for example, I have the resistance per unit length of copper to be 1.33 times 10⁴. So I can just pick one of this and that of copper, or this and that of copper. I also have that of resistance per unit length of nichrome. Nichrome is 8.68 times 10⁻3. So you can see I can use copper and nichrome. I can use any of these wires. Any combination of this will just be fine. But for the purpose of this video, I'm going to use these two wires here, this resistant wire A and resistant wire B of Constantine wire. Why? The reason why I'm using Constantine wire is that Constantine wire is the most popular wires that you can find in your physics laboratory. Then sometimes you can also get copper wire. Okay. Then another thing you can do, you can also look up your textbooks and search the internet to get the resistance per unit length of these materials. You can get them from internet or from textbooks. Okay, so I'm going to be sticking with these two. And another thing that you need to note is that if you are going to use any of this resistance per unit length in this video, then you have to show that to your teacher, because your teacher, you need to get the resistance per unit length that your teacher is going to use. So you can also ask your teacher if he has the resistance per unit length for the wires that is going to use. So once you get the resistance per unit length for the wires that you are going to use, you are good to use. So you are good to go. So I'm going to show you the formulas which I've already worked out. What I just leverage on is just to use the balance point of this setup here and the resistance per unit to obtain my for my values. So what you just need to get is the resistance per unit length. Okay, so let's move on. So like I said I'm going to be leveraging on the resistance per unit length of the two wire Constantine wire A and B. So what I'm going to do, I have this formula, LS is equal to 100 divided by R plus I. So I have to obtain the value of R from the resistance per unit length. So this is the value of R. R is for the first wire A, it's going to be 3.9 times 10 to the power minus 1 times L, the lengths that are given in for the wires. So this is my wire A. This is my table for wire A. So these lengths are the ones I'm going to multiply with this. Now remember that the resistance per unit length are in per meters. So then you have to convert L to meters. So if you see that if I convert this 100 to meters, then I'll have 1 times this already. So when I have 1 times this already, all I have to do is to add 3.9 times 10 minus 1. Just add it to 1 and divide it divide 100 by it. So I'll get ls. Then I'll now get the values for this. So you see how that's how easy it is. So all of this must be converted to meter. So 1 meter, 100 cm is 1 meter, 80 cm is 0.8 meters, 60 cm is 0.6 meters, 40 cm is 0.4 meters, 20 cm 0.2 meters. So this is for wire B. So the same thing. So I have my table for wire A and my table for wire B. I just have to separate them to differentiate with them. So now let's get into the workings. I may not be writing too much on the screen that as you have here. So what I'm going to do is just to plug in these values and work them out. So I'm going to get this 3.1 exponential minus 1 is the same as 0.09. So this is basically 0.39 rather 0.39. So what I'm going to be doing is just multiply 0.39 times L. So for the first one, L is 1. So when I multiply 0.39 times L, I'm going to get 0.9. Then I'll just add that to this one here, then divide it by 100. So I don't need to start writing it down. Just from your calculator, just press it. 0.39 plus 1. That's going to give me 1.39. Then I'll do 100 divided by 1.39. So that gives me 71.942. So I'm going to write that to 79.9. Just one decimal place. So you see, one decimal place, that's enough. Now, there's something you can do. You can just adjust this a bit so that in your sentence, all of you will not have the same result. So you can write this as 79.6, 79.8, close, something close like that. It can even be 80.0, 80.1. That's fine. There's no big deal about that. So I'm going to get the next one. So I'm going to do the same thing now. My L now is 80. So I'm going to do 0.39 times 0.8, not 80, because I have to convert it to meters. So 0.39 times 0.8, that's going to give me 0.312. So I'm going to add the 1 to it plus 1. That gives me 1.312. So I'm not going to do 100 divided by that result. That's going to give me 76.219. So I'm going to record it to 76.2. That's how I'll leave it. And the next one, 60. So I'll do 0.39 times 0.6. That's going to give me 0.234. Then I'll add 1 to it. That's going to give me 1.234. So 100 divided by my answer, that's going to give me 81.037. So I'm going to give it to 81.0. Like I said, always adjust these values. You don't need to write the exact values. So you can just alter them by 0.1, 0.2, 0.3 plus or minus. Okay, so let's go to the next one. So I'm going to have 0.39 times 0.4. That's going to give me 0.14 plus 1. Then 100 divided by the answer, that's going to give me 86.505. So I'm going to write it to 86.5. You can adjust this as like I said. Then the next one, I'm going to have 0.39 times 0.2420. Then I'll add 1 to that. I got 1.07. Then 100 divided by my answer, that's going to give me 92.764. So I'm going to write that to 92.8. Like I said, you can adjust these values a bit by just 0. plus minus 0.01 to 0.04. Okay, so that's that. Now I'll leave this table now. I'll go and evaluate ls for this. So remember that for this, the length is where the resistance per unit length is 0.51. That is the same as this here. So what I'm going to do now, I'm just going to write 0.51 times L again. So now remember that the lengths are in centimeters, so you have to convert that to meters again. So how do I convert that to meters? I'm going to do this. So let me just pause this. I'm going to pause it, enter all the values. It's basically the same procedure so that the video will not be too long. So I'm going to pause it now and enter all the values. Okay, so these are my recorded tables. So I basically did the same thing that I did here with all of this. So to get the ly, you simply subtract this from 100, you get this. To get this, you subtract this from 100. Remember, the length of the wire on the bridge is 100. So to get this again, subtract this from 100. To get this, subtract this from 100. To get this, subtract this from 100. And to get this, just divide this by this. Since RS is 1 ohm, just multiply it by 1, so you get this value back. So RS is 1 ohm. So whatever you divide this by this, you get the same result as this. So this divided by this gives you this. And notice that all of these are recorded to 3 decimal places. So you have to record this to at least 3 decimal places. The same for this. So to obtain this, so what I simply did to obtain the value of LS was to multiply 0.51 times the length here, add this to this one, then divide the result by divide 100 by the result. Okay, so when you do that, so the first one is 0.51 times, remember that the lengths are in centimeters, so you have to convert it to meter, divide it by 101. When you multiply, that gives you 0.51. Add it to this one, that gives you 1.51. So 100 divided by 1.51 gives you this to 1 decimal place. So all of these are evaluated to at least 1 decimal place. So I try to evaluate them to 1 decimal place because it's going to be better. But for this result here, to at least 3 decimal places. Do not forget that. So this is my table. So you see, it's very easy just by applying the basic theoretical knowledge of the meter bridge. You'll be able to arrive at an answer. So like I said, if you find you want to know how I arrive at this formula, notify me. I can do a separate video on that, on how to get it. So the next thing we have to do is to plot the graph. So I'm going to plot the graph. Remember, we have to plot the graph of R2 against R1. So let us go plot the graph. Okay, all right, so now let's plot the graph. Now there's something you need to note on this. So on this, you can see that there's a trend on this. As the length L increases, LS also increases. Sorry, as the length L decreases, LS increases, and LY then decreases. So also with this, so you can see that there's always an increase in this and a decrease in what? This. So if there is a trend like that, that means what you have done is actually what? Correct. Okay, now let's quickly plot the graph. Now there are ways that I normally plot my graph that makes it look very easy. So when you have values like, so remember we are plotting R2 over against R1. So what I'm going to do is this. On this part here, I'm going to divide this. I'm going to divide this into 10 places. So what I'm going to do is this. So I have 0.25 as the highest here. Now to make my work very easy, why am I dividing it into 10 places? I'm dividing it into 10 places so that I can fit it into 10 buses here using 2 cm to represent 1 ohm on these axis. I will also do the same on this. So by doing this, I've already chosen my what scale. So what I will do is this value here is the least value here is 0.078. So I'll take that to 0. Then this is 0.250. I can leave it at 0.250, but the easiest thing for me to do is to move it to 0.5. So that's what I normally do. So if I move it to 0.5, now if the value is greater than 0.5, like we have here, I'm going to move it to 1. So that when I divide 1 by 10, I'm going to get 0.1 for to represent 2 cm. So if I move this to 5, then I divide 5 as 0.5 by 10, I'm going to get 0.05 to represent 2 cm. So by so, I'll be able to fit in the values into all of this. Okay, so what I've just said is this. I'll move this. This is 0. So I'm going to start it from the origin 0. Then I'm going to move this to 5 as 0.5. So when I divide 0.5 by 10, I'm going to get 0.05. on the horizontal axis. So that has been sorted. So on the horizontal axis, I'm going to get 0.05 on the horizontal axis. Okay, then on the vertical axis, I'm going to move this, since the value is greater than 0.5, I'm going to move it to 1. So I'm going to divide 1 by 10, and that's going to give me 0.1. So it means that on this side, I'm going to fit 0.1. So what I'm going to do now, let me first of all draw my X and Y axis. So let me put it on the zoom that we can see clearly. So I'm going to draw my X and Y axis. Okay, now note this, do not start your graph from the bottom side. You can, this is 2 cm, 4 cm, 6 cm. Let me see if I put my 0 here and check if I can get 10 values from here that will fit into 0.5 or 0.6. Remember, we are using 0.1 on this axis now. So if it fits into 0.6, that is if it's greater than 0.5, I'll start it from here. So this is 0, 1, 2, 3, 4, 5, 6. So you see it's enough. So I'm going to start this from here. Then again, before I draw my horizontal axis, so I don't want to start it from here. The reason why you do not want to start it from here is that if you, from the downside is that if you have a negative intercept, you will not be able to read it up from here, and you'll be penalized for that. So for this, I have to check if I can get 0.25 on this side. So if I go 0.05, 0.1, 0.15, 0.2, 0.25. So you see it fits into it. So I can start my graph from this part. That's what I said from here. So I'm going to draw my X axis, my Y axis through this part. So from here, I'm going to draw it. Okay, from here. So I'll draw it upward. So it's very important to note that, because you'll be penalized if you have negative gradients and you can't fit them into it. Okay, so this is my origin. So this would be 1, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. You want to extend it upward. Always ensure that your graph is at least 2/3 of the whole paper, your graph paper. So I have to extend it beyond this, 0.7, 0.8. Then I'm going to write what I'm plotting down this way, arrow 2 in ohms. Okay, you can also write it on this side if there is space for that. Then the next one now, we'll get the horizontal axis. So this will be 0.05. Okay, then this would be 0.10. So when you add 0.05 together, it's going to give you 0.10. So this will now be 0.15, 0.20, 0.25. That's what is required for this, but you still need to move it beyond that, extend it upward. 0.30, 0.35, 0.40. That's okay. Then put whatever you are putting here. That's arrow 1 in ohms. Now the reason why I made this to be in ohms is because L is in cm and L is in cm. When they cancel at each other, you'll be left with what? Just the resistor. That makes it to be what? In ohms. Then after you have drawn this, now this is what I'm going to do. I am plotting arrow 2 against arrow 1. Now these values, I'm going to convert them to the number of squares on this. How do I convert that? Now remember that on the vertical axis, 0.1 cm, like we did here, represents 2 cm represents 0.1 ohms. Okay, so I want to know what will be the value for each of these small lines, small squares here. So what I'm going to do, I'm going to count the number of small squares. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So it means that 0.1 is divided into 10 smaller squares. So I'm going to divide this 0.1 by 10. When I divide 0.1 by 10, I'm going to get 0.01. So what that means is that each of these squares, small squares, will take 0.01. So if each of the squares takes 0.01, then how many small square with 0.51 take? So what I'm going to do is this. I'm going to divide this by 0.01. So let's see. So if you see 0.511 divided by 0.01 would just be 1212, would be 51.1. So this is the arrow 2 ohm. So I'll have that here, 51.1. Then when I divide 0.408 by 0.01 again, I'm going to get 40.8. When I divide 0.304 by 0.001, I'm going to get 30.4. When I divide 0.203 by 0.001, I'm going to get 20.3. And for the last one, obviously, I'm going to get 10.3. Then I'll now do the same for this. Now for this, we said that 2 cm represents 0.05 ohms, as you can have here. So when you count the number of small buses, it's going to give you 10 again. So I'm going to divide 0.05 by 10. When I divide 0.05 by 10, I'm going to get, so that gives me 0.005. So the next thing I have to do, I'll come to this place. I'll divide all of this value by 0.005. So 0.250 divided by 0.005 is 50. Then I'll do 0.312 divided by 0.005 is 62.4. Then I'll do the next one, 0.235 divided by 0.005, that's 47. Then the next one, 0.156 divided by 0.005, that is 31.2. Then the next one, I'll do 0.078 divided by 0.005, that is 15.6. So these are the values that are required to plot on my graph. So the essence of doing this is that you won't be stressing yourself trying to find the smallest point inside this graph. So if I want to plot this against this now, I'll just come to this place. I'll look at 51 against 50. So just come this way. This is 10, 20, 30, 40, 50. So I'm going to 51.1, which is almost as 51. So this is 10, 20, 30, 40, 50, 51. So I'll put a dot here and circle it. As easy as that. Next, 40.8, 62.4. So I'm going to come to this place. Remember, this was 50. This is 60, 61, 62. So this is 62. 62.4 is closer to the midpoint. So just 62.4 will be at the middle of 62 and 62. So use your description to do that. So I'm going to 40.8. So this is, if I just put on top of this, this is 10, 20, 30, 40, 45. Okay, it's 40, 40.8. 40.8 should be at the middle here. So this is, just move this way, 1, 2, 4, then come back here and put a dot. Okay. Next, we'll go for 30.4 and 47. So let's go to 47. So we go to 47 for 30.4. So this is 10, 20, 30, 40, 45. So I'll move it to 30. This is 10, 20, 30. So 30.4 should be at the midpoint. But remember, we are going to 47, and this is 45, 41, 46, 47. Then I'll go up a bit here and put my dot here. Okay, next 31.2 for 20. These are basically 31 and 22 because they are not up to the midpoint. So you can approximate at 31 and 23. So this is 10, 20, 30. Okay, then we go to 20, 10, 20, 31. So I'll put a dot here and I'll circle it like this. Next, I'll go to 15.6 for 10.3. 15 for basically 10. Just use your description, 15. So this is so this is 10, 10. This is 15, 15. Then we are going for 10. So this is 10.6. Use your discretion and put it at the middle here. Then you circle this. So now we cannot draw our line of best fit. So I'll draw my line of best fit because this looks like an outlier. If a line that is, or a point that is way off what is required. So I'll just come to this place it on top of this. So you can draw it on any of these. So I have a very straight line. So I'm going to draw it on top of this. Draw it to any length and draw it through this. So this is my line of best fit. So to determine the slope on any of these, you can draw a straight line on any of these. Let's say this, and allow the triangle to be big. So I'll draw it on this. Use broken lines. I'm going to draw it to this. Draw a large triangle. So let me draw it up to this point here. Okay, then on this one I also draw it on this point, a large triangle. Don't draw, some students they find the habit of drawing very small triangle. You'll be penalized for drawing small triangle. Draw a large triangle. You don't want to be losing mark, you want to gain more mark to help improve your grades. So you draw it to this point. So I'm going to read off this point. Then I'm going to read off this. So you can easily read off this point. So on this point, draw it this way. So this point is going to be delta arrow 2, and this side is going to be delta arrow 1. So the slope S would be equal to delta arrow 2. So what I'm going to do again, I'm going to use my scale factor again. This scale factor that I use here, 0.01 and 0.0. So to read this point off here, just count the number of square. This is 10, 20, 30, 40, 45, 46, 47, 48, 49, 50. Okay, it's 49 here, 49. So 49 times 0.01, that's going to give us 0.49. So I'm going to have 0.49 minus, so you can easily read off this point here. So this should be midpoint of 0. So that will be 0.05 divided by, so here you are going to read this point again, use the same scale factor for the 0.05. So that will be 10, 20, 30. Okay, in fact, this is the midpoint between this and this. So you can easily get the midpoint between this and this by adding 0.40 and 0.35 and dividing it by 2. So this point will be 0.375. 0.375 minus, so you read off this point. So again, you can just count this. This is 5, 6, 7, 8. So you do 8 times 0.05. So that point is 0.04. This, they are all in ohms, so they will cancel at each other. The unit will cancel. So when you subtract 0.49 minus 0.05, that's going to give us 0.44 divided by 0.375 minus 0.04. That will give us 0.335. So when we divide this, that's going to give us 1.3, approximately 1.31344. 13. So that's approximately equal to 1.13. And then we asked to evaluate x is, or k is equal to the square root of x. So we'll just take the square root of 1.313. So I'll take that. And that's equal to 1.145. 1.145 approximately. So do not forget to write the scale that was the title of the graph. So this will be the graph of R2 in ohms against R1 in ohms, and the scale used, we have the R2 axis. Please do not use Y axis. R2 axis, we have already determined the scale from the beginning. That's 2 cm to 0.1 ohms. And the R1 axis, we have 2 cm to 0.05 ohms. So that was what we used here. So basically that is all about this practical. Very easy going and straightforward. So I hope to see you in the comment section, and as usual, do not forget to like, subscribe, and tell us what you feel about this. That your comment, your opinions will go a long way in helping us to improve on this channel. See you, and good luck to you.